using trigonometry in 3D shapes with adamonlinetutoring. Here is the beginner question, one of the easier questions that you're likely to find on this topic. Trigonometry in 3D involves applying trigonometric principles to solve problems in three-dimensional shapes, typically involving cuboids, pyramids, or other geometric solids. This usually includes finding lengths, angles, or distances within the shape. For this question, we need to find the angle EDG. E to D to G is represented by this right angle triangle, where the angle EDG here is to be found. Problems often reduce to identifying and working with one or more right angle triangles within the 3D structure. If we take the right angle triangle highlighted red and represent it 2D to the right hand side, going from E at the top down towards G where the right angle is, across to D, and ultimately the question is asking us to find this unknown angle, which I will label as theta. I already know that this length that goes from E to G is the height of the cuboid, which is given at the front going from A to C and would be the same measurement of 3 inches. We just require one more bit of information from this right angle triangle, the length of the hypotenuse going from E to D, or this length which is the adjacent going from G to D. Then we'll be able to use basic trigonometry, SOHCAHTOA, to find the unknown angle. Since we don't have enough information, we'll use another right angle triangle, which involves a shared length with GD. Using the right angle triangle that lies across the base of the shape, where this is the right angle, I should be able to find this shared length of GD. Again, pulling the triangle out as a 2D image to the right hand side, it goes from G down to C and across to D. Notice how the length GD is on both of the right angle triangles. From the blue triangle, I know that the length GC is the depth of the cuboid, which can be found here, which is 8 inches. And I know that the length that goes from C to D runs across the width of the cuboid, which is given here as 5 inches. Using Pythagoras' theorem, I have the two shorter lengths, so I can use these to find the hypotenuse, the longer length, labelled as GD. This will be the square root of 8 squared plus 5 squared, which is the square root of 89. To avoid any rounding errors by the time I get to the end, I'll keep this as an exact value, root 89. This is the same as the length GD on the triangle originally highlighted red. And now I have enough information to work out the missing angle theta. Labelling my triangle, the length opposite the angle will be labelled as O for opposite. Opposite the right angle will be labelled as H for the hypotenuse, which means that next to the angle will be labelled as A for the adjacent. Circle the two that are involved in the question. I've been given the opposite and the adjacent, so this question can be answered using the tan ratio and the TOA part of SOHCAHTOA. Since I'm finding the angle, I cover up the ratio, and this tells me that I need to do inverse tan, and the opposite is above, so I'll be dividing the opposite by the adjacent. 3 divided by root 89, meaning theta is equal to 17.6406, which when rounded to one decimal place is 17.6 inches. Here's the intermediate question with a slight increase in difficulty. This time we need to find the angle between EM and the plane EDFC. E to M is from here to here, and the plane ADFC is the face running along the base of the 3D shape. So we need to run a line in the same direction as EM, but running along this base or plane in this direction so that we finish directly below E, and that forms this right angle triangle highlighted red. I can pull this right angle triangle out to the side, running from E to M to the point directly below E, with my right angle being located here. The angle between the line EM and the plane will be the one formed between the two, which has been highlighted. I'll label this as theta. We know what the length that runs from M to directly below E is, since this is exactly the same as the depth of the triangular prism and is given as 25 centimeters. Similar to the beginner question, I can find the unknown angle if I'm able to find one of the other lengths on this right angle triangle. That will involve using another right angle triangle with a shared length, and the one that will be most helpful is this length that runs from E to directly below. where I can use the triangle E to F to this point. Pulling this triangle to the side, this will be useful to find this unknown shared length, since I know that this angle is given at the front of the prism as 59 degrees. The length that runs from D to F is given as 10 centimeters at the back of the prism, which means that halfway to F would be 5 centimeters. I now have enough information to use basic trigonometry SOHCAHTOA to find the shared length. The shared length is opposite the angle, so labeling this as O. The one opposite the right angle is the hypotenuse, meaning 5 is the adjacent. Since the question involves finding the opposite when the adjacent is given, I'll be able to use the tan relationship and the TOA part of SOHCAHTOA. I'm finding the opposite, so I'll need to do tan of the angle, 59, and multiply this by the adjacent length of 5. This gives me 8.3213. Now I know my shared length, I can use this to work out the angle between EM and the plane EDFC. Always use a rounded value, one more decimal place or significant figure than what the final answer needs to be written as. This will avoid any rounding errors by the end of the calculation. Labeling the triangle, the shared length worked out would be opposite the angle. Here's my hypotenuse, meaning that 25 is the adjacent. The two lengths involved are the opposite and adjacent, which will be the tan ratio again. This time I'm working out the angle, so I'll cover up the ratio, meaning I need to do inverse tan of the opposite divided by the adjacent. 8.32 divided by 25. This gives me 18.41, which will round to 18.4 degrees to one decimal place. Here's the advanced question, one of the trickier questions that you're likely to find on this topic. The diagram shows a pyramid with base ABC, and we need to calculate the size of the angle between the line AD and the plane ABC. The line that runs from A to D is here. This is the plane ABC, so I'll need to run a length across this highlighted base in the same direction as the line AD, which will run across from here to be directly below D. So the overall question is asking me to find this angle formed between them. To do this, I'm actually missing the majority of the information. I know nothing about any of the lengths of this right angle triangle, so I'll actually need to use 2 additional triangles to help me find 2 of the lengths on this red triangle. One of them will be this blue triangle, which is right angled and runs from D to C to B. This will allow me to find the shared length CD. The other will be the green triangle, which forms the front face and runs from A to B to D. This is actually a non-right angle triangle, meaning I'll need to use my understanding of the sine and cosine rule rather than basic trigonometry with SOHCAHTOA, and this will help me to find the shared length that runs from A to D on the red triangle. Starting off with the blue triangle, I'm using this to find the shared length DC. The angle formed between DB and C is given as 34 degrees, and the length that runs from B to C is also given as 20 centimeters, labeling CD as the opposite, BD as the hypotenuse, meaning that BC is the adjacent. The question involves finding the opposite, and the adjacent is given. I can use my tan ratio. Since I'm finding the opposite, I'll cover this up, and this tells me to do tan of the angle multiplied by the adjacent length. Tan of 34 multiplied by 20 gives me a length of 13.4901. I'm rounding my overall answer to one decimal place, so I'll label the length CD to 2 decimal places as 13.49. Next, looking at the green triangle, I can label this angle as 45 degrees, which is given. I can also label this angle as 60 degrees, which is given. This will allow me to find the missing angle in the triangle by doing 180 minus these 2 angles, which gives me 75 degrees. Ultimately, I want to use this to find the shared length of AD with the red triangle. I have the opposite angle, which is great, but I need to know either the other 2 lengths to use the cosine rule, or another pair of opposite angle and length to use the sine rule. It will be easier to find one of the other lengths to use the sine rule, and that will be the one that's opposite the 75 degree angle. DB is a shared length with the blue triangle, which I looked at before. It's actually the hypotenuse, and previously I worked out the opposite length to be 13.49. So now that I know both of the shorter sides, I can use Pythagoras to find the hypotenuse. So the square root of 13.49 squared plus 20 squared gives me the hypotenuse of 24.1243. That would be this hypotenuse, which is shared with this length here, meaning this is 24.1243. Now I have enough information to use the sine rule. I have two pairs of opposite lengths and angles where one is unknown to be found. I'll use the version of the sine rule where the unknown length forms the numerator. So the length AD over sine of the opposite angle, 60 degrees, is equal to the other length, just worked out to be 24.1243, over sine of the opposite angle of 75 degrees. Multiplying both sides by sine 60 gives me 24.1243 multiplied by sine 60 over sine of 75, and this will give me the length AD, which is 21.6293. This is the shared length AD on the red triangle, so I can go ahead and label this as 21.6293. And now I have enough information within the red right angle triangle to use basic trigonometry SOHCAHTOA to find the unknown angle. Labeling, this is my opposite, this is my hypotenuse, this is my adjacent. The question involves the hypotenuse and the opposite, so I'll be able to use the sine ratio and the SOH part of SOHCAHTOA. Since I'm finding the angle, I'll cover up the ratio, so I need to do inverse sine of the opposite length divided by the hypotenuse. The opposite was worked out to be 13.49, and the hypotenuse was worked out to be 21.6293. This gives me an angle of 38.5861, which when rounded to one decimal place gives me a final answer of 38.6 degrees. Here's a question that I completed earlier. It appears as though I've made some mistakes. Pause the video and let's see if you can spot what they are and write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.